All right, so we have some problems that a little bit more like collisions. Still conservation of momentum, but speaking more in terms of collisions rather than just kind of both starting at rest. Okay, so in 44 here, we have a 1.35 kilogram block of wood is at rest. So block of wood there, totally at rest on a smooth table, meaning no friction. Then a 0.0105 kilogram bullet moving horizontally with a speed of 7.15 embeds itself within the block. What is the speed of the bullet block system after the collision? So to embed means it's stuck in there. They're moving off, going up as one. So we call this a completely inelastic or perfectly inelastic collision. That's when two things stick together. That's like the Velcro sides of the cards facing each other. So you've got this really fast bullet coming in here, very fast, 715 meters per second. So this is your, say, before picture, then your after picture is you have your wood block, bullet embedded within it, moving off at some speed that way. Okay, so conservation of momentum, M1, V1 initial, plus M2, V2 initial. Now this is a perfectly inelastic collision. They're stuck together. You have two masses merging into one mass. So you only have one final velocity. So you combine the masses, multiply by V final. That's your conservation of momentum equation for a perfectly inelastic collision. So, the initial values, say this is the bullet, 0.0105 kilograms, 715, the wood block was not initially moving, so we can cancel that out. Then we have both of their masses that are now combined, and we can solve that for V final. So, mass of the bullet, 0.0105 kilograms, multiplied by 715 meters per second. Again, the wood block is not moving, so it has no momentum. Then combine the masses, 0.0105 kilograms, plus the mass of the block, which is 1.35 kilograms, then multiplying by V final. Okay? Multiply this side out, add this side up, divide both sides by this new combined mass. And we should get a final value of about 5.52 meters per second. I'm looking at the right one here, 44. Yep, 5.52 meters per second is how fast the two will be moving after that collision. All right, then on 45, similar type of problem, except for both things are moving, but in the same direction. You have a small truck going slow and a big truck going fast. So, 1,200 kilogram car moving at 2.5 meters per second is struck directly from behind by a 2,600 kilogram truck moving at 6.2 meters per second. Okay, so let's just draw this up here really quick. Small truck going a low speed that way of 2.5 meters per second. And coming up behind it is a much bigger truck traveling at a much faster speed. 6.2 meters per second. This having a larger mass of 2,600, and this with the lower mass of 1,200. So they are, it says if the vehicles stick together after the collision, what is their speed immediately after colliding? Again, assuming external forces are ignored. So they are merging together. They are getting stuck and entangled with each other and moving off as one big thing. So if this is our before, Our after is now we have one big entanglement of trucks with a big mass moving at some speed that way. So we can still use conservation of momentum equation for perfectly inelastic collisions. So we have m1 v1 initial plus m2 v2 initial is equal to m1 plus m2 multiplied by v final. Now, this is a good problem, but we could also set up the exact same problem, but they're headed towards each other. Now, if that ever comes up, remember that directions matter. That if these had opposite velocities, they would have to have opposite signs, meaning one would have to be positive, one would have to be negative. That's not the case here, but just, in case that comes up in another problem. Okay, so we have all these values here. We can just look right off of our picture. So we have 1,200 kilograms. Just write the numbers so I have enough space. Times 2.5 meters per second plus 2,600 kilograms times 6.2 is equal to, erase some of this, another space here, just need the after picture. The new combined masses, which is the first mass, 1,200, plus the second mass, 2,600, times the final velocity. And that's what we have to solve for. Everything else in the problem's all filled out. Add this, divide both sides by that new combined value, 3,800. Add everything over here. Again, everything's all going the same direction, so we don't have any negatives to deal with. When we do our math there, should get a V final value of 5.0 meters per second. So the new combined, and that makes sense. This velocity is right in between the 2.5 that the smaller one had and the 6.2 that the bigger one had. It's going to be a combination of those two, but kind of more weight, no pun intended, is given to the one with more mass. Because it has more momentum because of that more mass. So again, just so we double check that we don't wind up with an answer like 1.2 or 8 or something, that wouldn't really make sense. It makes sense that it would be between the two other values.